So here is the first session on vector integration. So in the last three sessions, actually we seen first of all the velocity and acceleration. Then the second session is about a gradient, and the last session is a divergence and curl. So in today's session, we are starting the vector integration now. Just like vector differentiation, we have vector integration here. In vector integration, again, you have 4 articles. So today we'll complete 1 article and tomorrow 3 articles, because the 3 articles are just for verification. None of the question is for verify there. Just we have to evaluate with the help of theorems there. That we'll see in the tomorrow's session. So the first article from vector integration that we have is work done here. Okay. We'll see. The question is about work done for a moving particle. So this is exactly same definition that we learned in our linear motion. We know force into displacement. Force into displacement is a work done, is it? So only the difference is here. This particle is moving on the curve. So this particle is moving on the curve C. Okay, this is the position vector r bar. This is actually a displacement vector r bar. Okay, with respect to origin, this r bar denotes the position of a particle, as well as r bar is known as a displacement vector, and because of that only we already seen that dr bar by dt is the velocity vector. Yeah, correct, and the tangent there. So here suppose this particle is moving on this curve C under the force F bar. Suppose that force is some vector, say this is the vector F bar. Under the action of the force F bar, that particle is moving on that curve. So here is the particle and this force F bar is acting on it. So this is force vector, this is the displacement vector. So the work done is an integration of that force into displacement. So integral F bar dot dr bar. So it's a dot product now. So F bar is one vector. So we know F bar, this F bar is given, say F1i plus F2j plus F3k. This is the F bar vector. And say r bar is xi plus yj plus zk. So this is one standard vector. That's a position vector is always denoted as xi plus yj plus zk. So this is the standard notation for position vector. So our dr bar, that dr bar vector will be dxi plus dyj plus dzk. So it is a total derivative formula actually. So dxi plus dyj plus dzk. So if you take a dot product of this integral f bar dot dr bar on the curve C, that is nothing but it is f1 dx plus f2 dy plus f3 f3 dz. So if we integrate this, we get a work done for a moving particle on the curve C. Is it clear? Is the formula clear?
Yes, sir.
Okay. Now the most important thing now you'll observe, we have to integrate f1. See, this is a very important part. Now focus only on the formula. This formula is only important. You have to remember work done or the line integral over the curve C. So the name is also known as a line integral. Why that is a line integral? We come to that. We'll come to that. Because we are integrating only on the curve. Because of that, the name is given as a line integral. So this integration is only on that path or only on that curve. This integral is also known as a circulation of a fluid under the force F bar. Suppose some flow is there and that flow is on some path, on this path C. On the path C, we have some flow, and if you want to find out the amount of flow from point A to the point B, and instead of that F bar, this F bar is a force vector. Instead of force vector, it is a velocity of the flow. So that F bar is a velocity of the flow, then F bar dot dr bar, that gives a circulation of the flow. Okay, so we'll not go in that detail, not required. Just right now I will tell you where you have to focus. You have to focus on this formula. Okay, focus on this part only. Now our aim is to integrate this in every example. You'll observe our aim is to integrate f1 with x. We have to integrate f1 with x, we have to integrate f2 with y, and we have to integrate f3 with a z. But here there is no condition like when we integrate with x, we have to treat y and z as a constant. Okay, because we are not integrating some partial equation there, partial differential equation. So in previous session, we taken that to get that function phi, we have that integral of f1 with respect to x treating y and z as a constant, because this phi is obtained from some partial differentiation. Because of that, we can treat yz as a constant and we can integrate it, because we already know that dou phi by dou x is f1 there, and when we integrate phi with respect to x, we treat that yz as a constant. So that's the reason we are writing that yz as a constant, and we integrate that way. But here, when we integrate this f1, f2, f3 with respect to that variable, the other variables are not constant, and because of that, all the line integrals are done in a parametric form. So this is the most important thing. The most important thing what you should remember, all line integrals we can evaluate only in a parametric form. Only in a parametric form. So whenever we have the equation of a curve, that equation of curve we should write in a parametric form. Then only integration is possible. So let me come to some standard equation of curves. We discussed earlier this part. So I will just show you here. Okay, before that, this is one important property regarding the conservative field. When the f bar is a conservative field, conservative means irrotational field, that means there is no rotation in the vector field, then the integral over a closed path C, so this C should be a closed curve, and if what is example of a closed curve is a circle, ellipse, square, triangle, okay. But if we do that integration over any closed path, and if we get that integration of f bar over the closed path is a 0, we say that f bar is a conservative field or irrotational field. There is another interpretation of this equation is, so like already I said, suppose the closed path is like this. So here is a point A and here is a point B, point A and point B. One path I taken this as like a straight line, and another path I take like a, suppose a circle, arc of a circle. So if we find out work done over the line AB, on the line AB, suppose it is coming 10 unit, then work done over the arc AB is also 10 unit, then we say it is a conservative field, because the work done doesn't depend on a path, it mainly depends on the initial and end point only, the initial and end point. But conversely, if I say work done over a closed path means, for example, if you calculate work done over AB, it is coming 10. But if you calculate work done over BA, this is reverse direction from B to A. Okay, that time the work done will become minus 10. So net work done over the from point A to again point A, coming plus 10 minus 10 as a 0. Hence, work done over closed path is a 0, because the direction opposite, so automatically minus sign will appear in the work done, and total work done will become 0. Hence, it is a conservative field. So just remember the property, not that much required. Okay. And now this last part, the parametric form. Few standard equations of the curve are written on the screen. We want its parametric form. I want one by one. Okay, just I will ask the questions now. So can anyone tell me the parametric equation for the circle now? What is a
R
circle?
Like
cos
we
theta,
can
R
take
One
a
by
sin
one.
cos
theta.
theta.
Only Jain, Rushil Jain. Yeah.
Sir, A cos theta, A sin theta.
Yes, very good. X is a cos theta, y is a sin theta. That's a correct answer. Okay. Now, Bijay, tell me for the second ellipse. Saurabh,
Yes, sir.
for ellipse.
X equal to AB sin theta, Y equal to AB cos theta.
Not correct. Abhishek Kumar.
Is facing some network issue.
Okay, network issue. You can tell me them.
Yeah, x equal to a cos theta, y is equal to b sin theta.
Okay, correct, Ayush. X is a cos theta and y is a b sin theta. That's a correct answer. This is for ellipse. Next, for parabola, can okay, Adarsh, Raj. No. Yes, who will answer? Ayush.
Sir, I
A
80 square comma 280.
Yes, x is 80 square, and or it is very simple, na?
So
You
t square by 4 is it
no.
directly?
हाँ
80
डायरेक्ट
स्क्वायर एंड 280 उसका डिफरेंशिएशन है।
E square and 2.
no I want simple parametric form. Why you go in the standard forms? No need actually. Parametric forms you can easily get, you can very easily get it from the equation only. Yes, we discussed about it. Yes, Pratyush. Okay, you are not audible actually. Okay, so I will tell you the answer. The answer is just put x as a t. If x is a okay, or okay, that way is also okay. So if you put x is t, y becomes root of 480, that is 1, or put y equal to t and x become t square upon 4a. Is that clear? Y is a t and x is t square upon 4a. Now one last, what about the straight line? Yes, Pratyush.
Sir, x is equal to x plus 80 times.
No, x is
X is t, y 2t.
okay, that is a better. X is t and y is 2t. I think Pratyush given in theta but not required. Okay, you see here all these parametric form I will show you here. These are the parametric forms, and you have all the solutions now in front of you. So you'll observe for circle, for this circle, this is the parametric form. X is a cos theta, y is a sin theta. These are standard parametric forms. Okay, mainly first two. Yes, remaining just you put uh, all x, y, z should be in some parameter mainly. Okay, and all these curves you'll observe it is in two dimension. It is in xy plane. As they are in xy plane, obviously z is a zero, and dz is also zero. Okay, so that you require later on. We'll come to that part. We'll come to that part. Okay, so that about the theory. Now we'll move to the questions, the numericals now. So I will take a first question on the screen. So here is the first example. You can see the first example there. Question is, just a minute. Just a minute, okay. Okay, so the question is find the work done for moving once around the ellipse. The equation of ellipse is given. The meaning of z equal to 0 is this ellipse is in xy plane. Okay, sometimes it is given or may not given. So even though z is not 0 given, you clearly observe this ellipse is in terms of xy, so z is 0 there. And the force vector is given, and the question is this field conservative? Is this field conservative there? Okay. Step number 1, you should write a formula. What is the formula? What is the formula?
Integral
Integral of
integral
f
f
dot
dot
F dot
dr.
dr.
Okay, integral of f bar dot dr bar, correct. So this is the formula you should remember. Work done is integral f bar dot dr bar over the curve C, which is integral f1 dx plus f2 dy plus f3 dz. Next step, anyone? Guess?
Taking parametric form.
Sir,
Instead of parametric, first let me replace f1, f2, f3 values, because we have these values. No? We are given f1, f2 and f3. So this is vector f bar, which is f1i plus f2j plus f3k. So the next step, I just replace the values of f1, f2, f3 there. Okay, nothing else. And now that answer is correct, let me write the parametric form of the curve. So what is the parametric form of this ellipse? What is
pi
this?
a cos
A
theta
cos theta b sin theta.
and b.
No, Rushil, yes, tell me.
Sir, 5 cos theta
Okay.
and 4 sin theta.
Correct. X is 5 cos theta, y should be 4 sin theta, and z is a 0. That is the parametric form. So this is the first thing you should write. So for this curve, x is 5 cos theta, y is 4 sin theta, and z is 0. But you will observe in the throughout this integral, this x, y, z values we can replace in parameter theta, but at the same time we require the values of dx, dy, and dz also. So let me differentiate. What is the dx?
5 sin
Minus
minus
5
5
sin
Minus
theta.
5
Minus
sin
5
theta.
sin theta.
Yes,
minus 5
yes,
sin
Sahil, you can tell. Yes, dx
minus 5 sin theta.
minus 5 sin theta, d theta,
D theta.
yes, dy, yes, Sahil,
4 cos theta. 4
4
cos
cos theta, d theta, and dz
theta.
0.
0.
Okay, that's one. So this values you will get dx is minus 5 sin theta. I missed here d theta. Okay, my mistake. So don't forget it. here should be d theta, here should be d theta. So minus 5 sine theta d theta dy is 4 cos theta d theta, and dz is a 0. Now we'll replace these values of x, y, z, dx, dy, dz in this equation, and we get a work done. Now before that, what should be the limit of theta now? What should be the limit for theta? Because something is given in the question that
2 pi, sir.
0 to
0 to 2 pi.
yes 0 to 2 pi, because we are given one rotation on the ellipse. So we have to take one rotation on ellipse. So theta should vary from 0 to 2 pi, and that should be the limit here. The work done becomes integral 0 to 2 pi, and we replace just values of x, y, z. Z is a 0, so z is 0, and dz is 0. So only this is f1 dx and f2 dy. Dz term is not there. Got it? Any doubt up to here?
No, sir.
Now just to have to
Please explain the limits again.
limit is, we are given in the question that particle is moving once around the ellipse.
Okay, sir.
Okay, so that one rotation means theta 0 to 2 pi. Okay, that's one. Okay, now just to simplify, take d theta outside, and you'll observe this is 10 into 5, that is minus 50 sine theta cos theta. This is 20 sine square theta. Here is 20 cos square theta. So that term can be simplified. Let me just try the simplification here. So what happened? Just term by term multiplication and d theta taken common. Okay, these two terms can be simplified with the identity sine square plus cos square is a 1, and we get this term here, because this 16 minus 50 is a minus 34, and this is 20. Okay, so it is so simple calculation. Now only thing, this integration. Can anyone guess what should be the integration of this first term? What should be the integral value of this term over the range 0 to 2 pi?
So we'll write this as minus
By
17
substitution,
Okay,
sir.
one
sine 2
only.
theta.
Rushil, yes, you can tell.
So we'll write minus 17 sine 2 theta.
Okay, okay,
And then its integration as
correct.
Sir, if sir, if
Yes.
you substitute, sir, the sign is at t.
Okay,
Then we
that is
consider
also correct. Okay, both ways are correct. I think Vijay says substitution, Rushil says that sine 2 theta formula, both are correct. Both way you get the answer, but I will tell you the simplest rule. When the limit of the integral is 0 to 2 pi, okay, this rule is very useful when you have limits 0 to 2 pi, when integration is from 0 to 2 pi, and either sine or cosine, sine or cosine have the odd power. At least one trigonometry term have the odd power in multiplication. The integration of that term is a 0. The answer is a 0. Okay, this is the property. If you want, you can see
yes,
the
sir,
proof.
property of
Okay.
integration,
Okay,
sir.
yes. So
Odd even.
okay, yes, your choice. You can use that property, or you can do step by step. But I will tell you, you can just mark here arrow and 0 there directly, and only 20 d theta left. The integration of d theta becomes a theta, and what should be the answer then?
45.
45,
pi.
correct. Yes, very good. So the final answer is a 40 pi units. That is the work done. That is the end of a question. Okay, that is the end of the question. If anyone have a doubt, yes, you can ask.
Please explain that property again.
I will write that property better. You will understand it. The property says integration 0 to 2 pi sine raised to m theta into cos raised to n theta d theta is equal to 0 if m or n odd. Okay, either means if both are odd, then also it is 0. So at least one power of sine or cosine should be odd. Got it?
Okay, sir.
If both are even, both m and n are even, actually for m both even, it becomes 4 times 0 to pi by 2. 4 times 0 to
Yes,
pi by 2.
pi by 2.
Yes. Provided both m and n even. Both m and even. And tell me, when 0 to pi by 2 and this situation occur, how you can evaluate it?
Wallis
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 formula. Yes, you can use a Wallis formula to evaluate it. That's a better, or you can use the beta formula also. Your choice. But generally, this 0 mainly useful. Many times we come across 0 only. So just you have to do like this, and you can say that is a 0. That's it. I hope it is clear. Okay, so that about question 1. Now remaining questions are just similar. Three more questions I will show you, and then we'll take small quiz there of 3 questions today. Okay. So come to the next. Find the work done in moving a particle once around ellipse. It is actually duplicate example. It is just similar example there, is it? So I'll just quickly show you. Step number 1, the formula. Work done is integral f bar dot dr bar f1 dx plus, and then we have to replace the values of f1, f2, f3. This is the case. What is the parametric form for this ellipse?
4 cos theta 3 sin theta.
Yes, 4 cos theta 3 sin. X is 4 cos theta, y is 3 sin theta, z is 0. Then dx is minus 4 sin theta d theta, dy is a 3 cos theta d theta, and dz is a 0. We'll replace these values and integrate it. The answer you will get it as a 48 pi. Exactly similar way what we done like a previous question. I hope there should not be any doubt here in the second question. I dropped some steps here. I've directly written this answer. You should write it here. Okay, clear?
Yes, sir.
Yes, sir.
Okay. Yes, sir. Good. So the next, third one, second last question for today. So the question is, find the work done in moving a particle along this curve. Okay, the equation of curve is given, and from which point pi by 4 to pi by 2, that is also given. Under the force f bar is given. That is a question. So the best part for this question is the parametric equation of curve is already given. You don't have to think that what is that from Cartesian what should be parametric. Actually, this is equation. Can anyone guess what this equation represents?
Circle.
It's not circle. It's not circle.
Sphere.
It is not sphere. It is not a sphere. This equation represents a spiral. Okay, it is a 3D curve. It is 3D curve. Probably you can take like a spring also. Okay.
Yes, sir. Helical.
Helical that part. Okay, so
Helical, sir. Yes,
yes,
sir.
yes. So that about that curve, but we don't have to think about that curve. Nowhere you have to draw this curve. Just parametric curve equation given. We have f bar. We have the limits for theta also. The limits of theta also given in the question. So everything is given. Only the calculation is there. So start with the formula. The formula is, first of all, the x is given. The values of x, y, z is given. Therefore, we can compute the values of dx, dy, dz. So this dx, dy, dz is there. Okay, so from x we written dx, from y dy, and from z dz is written. Dz is a b d theta just. Now we replace these values in the formula of work done, that integral f1 dx plus f2 dy plus f3 dz. So this is f1, this is f1. F1 is taken from here. Okay, this is f1 dx. F2 is taken from here. Uh, I think I missed that a. I missed this a. Okay, don't forget to write a here. Okay, I will correct this. I will correct and I will share it this PPT. So a should be here. This a is missed there. Okay, next step I taken, I think, because while typing I made a mistake. So and here bracket is missed. This bracket completed here. Okay, let I correct it here only. Whatever the missing parts I will correct here only. So one a is missing here. This one of the a is missing. Then this bracket is completed here. This is a b sine 2 theta, that is a z, this f3 and dz. So that way it is done. And what about the limits for theta?
Sir, pi by 4 to pi by 2.
Correct. So that we have to mention there. Correct. So before that, let me simplify. We have to simplify this term by term multiplication. You have to do it and simplify it. So if we do a simplification, the simplified part will left this much only. 2a square sine theta cos theta and b square sine 2 theta. B square sine 2 theta you will get from this last term. This is b square sine 2 theta. And the simplification of these first two terms, simplification of these two terms is this one. And for this last term here. Okay, you can check later on. Okay, you can check that later on, because one of the term may gets cancelled. I think this term gets cancelled. This first term gets cancelled with this term, that term, and only this term left. 2a square sine theta cos theta, 2a square sine theta cos theta, and b square sine 2 theta. I hope that is clear. Can you observe some simplification? Just 1 minute. Yes. Yes, hello.
Sine to theta.
Yes, this is
So
sine
we
2
can take
theta.
sine to theta common.
Common, very good. That's one only. So we'll take sine 2 theta as a common, and integral of sine 2 theta is cos. I think minus sign I missed. Is it? There should be a minus cos 2 theta.
Yes, sir.
Yes,
Minus
sir.
cos 2 theta upon 2. Okay, there should be a minus cos 2 theta upon 2.
Yes, sir. Minus.
But yeah, correct. But when you put upper limit, you will get that cos pi by 2, that is a 0. Lower limit have minus sign, that minus minus become plus, and you get 1 by 2. Okay.
So
So
here the limits are wrong or what?
wrong, limits are correct. Limits are correct. I just forgotten the minus sign there. Limits 0. Sorry,
Pi by
correct, correct.
4 to pi by
Sir,
2.
limits
Pi
are
by,
from
yes, sir.
pi
Pi
by
by
4
2 to
to
pi by 4.
Yeah, my mistake. Yeah, correct. I typed in okay, in a very short time. Just last 1 hour I prepared these slides. So because of that, many mistakes left here. Okay, no issue. That's correct. All you are correct. So the first thing, the limits are not correct here. Pi by 4 to pi by 2 should be the limit. And here is a minus sign, minus cos 2 theta. And the limit should be pi by 4 to pi by 2 again. Correct. And now this a square plus b square is as it is. And when you put upper limit there, you get 2 gets cancelled, cos pi get.
cos pi is
0.
minus 1.
Cos pi is a minus 1. Okay.
Yes, sir.
The minus minus plus 1. Plus 1 by 2. Okay. And when you put pi by 4, cos
It becomes
pi
pi by
0.
2 with 0.
That's one. And now you get that required answer. And the required answer is, yes, the final answer is a square plus b square upon 2. The answer is correct there. Okay. Got it?
Yes, sir.
Yes,
So
sir.
that about this second last question. If any doubt is there, you can ask. Otherwise, I will move to the last question then.
No doubt, sir.
No doubts? Okay,
No,
good.
sir.
No doubt. No, sir.
Okay. Okay, so come to the last question here. So this is the last question. The question is, find the work done in moving a particle under the field of a force given by F bar. So this vector F bar is given in xy plane from the point 0, 0 to 1, 1 along the curve y square equal to x. Means first the particle is moving on parabola from this origin to 1, 1. And then we have to find out the work done. And there is one more part of the question: is the work done is a different on the straight line for the same points from 0, 0 to 1, 1? That we have to check it. Okay. So we'll start solution. So for the solution, step number 1, we write work done is integral f bar dot dr bar, which is f1 dx plus f2 dy plus f3 dz. The value of f1 is replaced here. So is f1 dx plus f2 dy only written. See, for f2 there is a minus sign. This minus sign is came here. Okay, so this is a, so this f1 dx minus f2 dy came because f2 is have that minus sign. And see the curves, both the curves are in xy plane only, or there is no f3. There is no f3. F3 is a 0. So f3 dz is not automatically not came there. Okay. So this is the formula for work done for this particular problem. Now we have to find work done for this parabola. So what should be the next step?
Parametric.
Parametric form for this parabola.
But
So what
this
is,
we can do directly
Parabola.
also because y is given as a function of x directly.
okay, that is also correct. Very good observation, and that is also one of the way of solving. You can treat y itself like a parameter. Okay, and you can go that way also. So, but some student always confuse, and because of that, I generally not suggest it. Those who are getting that part, they can directly use y as a parameter. So you replace every x by y square. You replace every x by y square, and you can proceed that way also. Okay, but I will do it with the parametric form. So the parametric form for y square equal to x is, so I taken y equal to t. If y is a t, x become t square, is it? So dy becomes
Yes,
dt
sir.
and dx become 2t dt. But can you tell me what should be the limits for t? What should be the limits of t?
So 0 to 1 only.
0 to
0
1
to 1.
only. Very good. And how we get that limit? From any one equation. See, limit of x is varying from 0 to 1 and y is also varying from 0 to 1. So here, if y is varying from 0 to 1 and y is t, then t should be varying from 0 to 1 only. So limit of t is 0 to 1 only. So let me replace these values of x, x as a t square, y as a t, dx by 2t dt and dy by dt, and we'll observe the calculation goes like this. This is a simplification, integration, putting upper limit minus lower limit. We get a work done as a minus 2 by 3. The work done is a negative. Okay, so work done can be a negative there. So minus 2 by 3 unit, whatever the unit of the work done there. Okay, that about the part 1 of the question. There is one more part. Is the work done different for a straight line y equal to x? So to calculate the work done for the straight line y equal to x, let me write a parametric form of the straight line. Again, here also you can do it in either y or x only, because you can treat y as a parameter or x as a parameter also. So I done case 2, y equal to x. So let y is t, so x is also t, dy is dt, dx is dt. Everything, this formula of work done becomes in terms of t only. And if you observe, t square gets cancelled and your answer again come as a minus 2 by 3. I dropped some steps, but you can do that calculation. So right now we observed here the work done coming same, even though the particle moves on this parabola. Okay, even though that particle moved on this parabola, the parabola is y square
Right
indicates,
hand parabola.
yes, right hand parabola, very good. And another is a straight line. So this is the point 0 0, and say this is the point is 1 1, and the particle at the beginning moved on this parabola and then on the straight line. On both the cases, the work done is a minus 2 by 3 only. So what you can interpret the result?
Conservative field.
Yes, the vector field f bar is a conservative field. That is the interpretation, and because of that this happened. Suppose we are given non-conservative field, and if we calculate a work done, we get a different answers then. We get a different answers there. But because of conservative field, we got here the same answers there. So the interpretation is not asked, but just the question is the work done is different? So you can say the work done is the same for both the path, or you can say the work done is independent of path, which indicates the vector field is conservative. That's one. Okay. So that about today's session.